Hello, welcome back. And this third model will be considering variation. But before I continue, I say remain your instructor, Mr. Awesome Emmanuel. Okay, let's just actually get started. Like I said, the topic before us is variations, and let's just lay some foundations and basics before we actually continue. A quick recap. Now, what is actually variation? Variation is just a mathematical concept that has to do with change or relationship. It actually has to do with relationship between two or more quantities. Now, let's just go through the theoretical background we have on the screen. Now, when we talk about variation, is the relationship that exists between two or more quantities in which the change in one quantity leads to the change in the other quantity. Now, what we're trying to say is this. For instance, when we have two or more quantities, let's say quantity A and quantity B, and we have a situation whereby a change in quantity A affects quantity B such that quantity B either increases or decreases. So this kind of concept is what we call variation. But for us to understand it perfectly, we'll be considering just basically two types of variation. But on the norms, we have about four types of variation. But for this case, we'll just consider the two types of variation we have for the scope of this lesson. And the variation we're considering is the direct variation and the inverse variation. The other two forms of variations are the joint variation and the partial variation. But let's just dwell with these two for now. And let's actually explain the difference between these two forms of variation. Now, let's start with the direct variation. Now, as the name implies, an increase or decrease in one quantity leads to the increase or decrease of the other quantity. For instance, if we have quantity A, now whatever happens to quantity A is such that it increases, and this increase in quantity A causes a resultant increase in quantity B. This kind of variation is what we call the direct variation. In the other way around too, if there is a decrease in quantity A and the decrease results to a resultant effect of decrease in quantity B, this kind of variation is what we call direct variation. So direct variation is when is the kind of variation such that an increase or decrease in a quantity, let's say A, result to a corresponding, take note of that word corresponding increase or decrease in quantity B. That whatever happens to A happens to B is called direct variation. Now, the inverse variation is just the reverse. Now, when there is an increase in one quantity, let's say A, and it leads to a decrease in the other quantity, let's say B, we call this kind of variation direct variation. Let me just paint a household example. For instance, your dad works with an oil company and you are the only child in the family. When your dad is earning, let's suppose your dad is earning, let's say, 5 million naira as monthly salary. You being the only child in the family, your allowance for the month will commensurate with your dad's income. Now, God forbid, something that happened, a new administration comes in and your dad is now earning 2 million naira. And with this period, the family has increased to like 3 children. You will not be expecting to get the same allowance you are getting before to what you are getting now. Having cognizance of the fact that your dad's income has actually reduced and the number of children in the family have increased. So in this case, as your dad's income reduces, even without the number of children increasing in the family, as your dad's income reduces, it affects your allowance too. So this is what we call a direct variation. What happens to your dad, the resultant effect is actually happening to you. That's what we call a direct variation. But the inverse variation is actually different. When there is an increase in one and leads to a decrease in the other, we call it inverse variation. For instance, when you're the only one in the family, you can eat a good number of food, but when the children are increasing, as the food is coming, the ration coming to you is getting small. So that is what we call the inverse variation. That is just on the friendly note. Now let's come to mathematics and see how we can actually apply this concept of variation to solve problems. But take note, from the foundation we have actually laid so far, variation just means change in two or more quantities. So with all these examples, let's solve them one at a time. Like I said, our emphasis is just on the two forms of variation we're considering here, the direct and the inverse. So let's start with this first example. Now, the question says, y is directly proportional to z. Now, if y is 3 and z is 6, find z when y is 12. How do we go about this? From the first statement, y is directly proportional to z. To write this statement mathematically, it means y directly proportional to z. Now, to remove this proportionality sign, we have to introduce a guy called a constant, and many times we use the letter k. So it means that y is equals to kz. We have to get a constant of variation first. Now, to get a constant of variation, what we're going to do is, from the first statement, y was given to be 3, we keep 3 here, and z is given to be 6, we keep 6 here. So to get our k now, it will be 3 divided by 6, which is 1/2. So the relationship between y and z is actually y is equals to 1/2z. Just the way there's a relationship between you and your dad. So now, can I calculate the second part of the question, which says find z when y is 12? So from this relationship, we can actually substitute the value of y to get that of z. From this place, the value to get z, or to make z the subject of the formula, z will be equals to 2y. So if z is equal to 2y and y is given to be 12, so to get z now, it will be 2 times 12, which is 24. Now, let's check something. Actually, the value of z is 24. Now, let's check something. Like from my explanation so far, that an increase in one leads to a corresponding increase in the other. Let's see if it actually works. When y is 3, z was 6. When y, this is 12. Obviously, this is an increase in y. So when y is 12, let's see what happens if z actually decrease or increase from this 6. We observe that z is 24, so this is a direct variation. Now let's come to example number 2. If a is directly proportional to n squared, a is 36 and n is 6, find the constant of variation. Now in this case, what we're going to do is a is directly proportional to n squared. So a is 36, so write 36 there, and n is 6. But n was actually given to us as n squared from the relationship. So 6 squared will give us 36. In other words, we'll have 36 equals to 36k. So to get our k now, the constant of variation is 36 over 36, which is 1. So the value of k is 1. That is, the constant of variation is 1. Now that is for number 3. Number 2. For number 3, m varies inversely as the square of p. Now, if m is 3 and p is 1, find the constant of variation. And this is how we're going to write it. Whenever you hear the word inversely, just put 1 over the next statement that was made. So m varies inversely 1 over. Now this is square of p, I'll put p squared. If it were to be cube of p, it would have been p cube. If it were to be square root of p, it should have been square root of p, as simple as that. So the emphasis I want to lay here is whenever you hear inversely, just put 1 over the next term mentioned. Now, we're told if m is 3 and p is 1, find the constant of variation. Now, from this place, we have to, if we want to make k subject of the relation here, so k will be equals to mp squared, that is when we cross multiply. But we're told that m is 3, so we'll put 3 here, then I'm actually substituting to this relationship now. Then p is 1, but observe or understand we have 1 p squared. So 1 squared is still 1, so 3 times 1 is 3, so the constant of variation is 3. I trust you understand what we're doing so far, so let's make progress. The next question is, x varies directly as y, and x is equals to 5.5 when y is equals to 8. Now find the value of x when y is 10. Now what we're going to do is, this is just a direct variation. So since we're not here inversely, we're not going to put 1 over y. So, and take note, it just very directly as y, not y squared, not y cubed, not square root of y, not cube root of y. So just keep ordinary y there. Now we'll bring our x equals to then ky. Remember, to remove this proportionality sign, we have to bring the k here. X is 5.8 and y is 8. So to get our k now is 5.5 rather, over 8. So I can just choose to keep it this way for now. So relationship between x and y is 5.5 over 8 all y. I'm substituting the value of k to the second step we had here. So now from the question, we should find the value of x when y is 10. So hence, when y is 10, x will be equal to 5.5 over 8, then multiply by 10, because y is 10 now, we're just substituting. So 5.5 times 10 will give us 55. Then divided by 8 will have 6.875. You can actually keep the answer in mixed number. So that is for number 4. So number 5, if x is directly proportional to y and x is 4 when y is 12, find the value of x when y is 24. Now this is actually simple. What we're going to do is similar as well. So x is directly proportional to y. So x is 4, we'll keep x there as 4. Then k equals to y, ky, we'll have ky, but y is 12. So to get our k now is 4 over 12, which is 1 over 3 when reduced to its lowest terms. Now the relationship between them is equals to x will be equals to 1 over 3y. Now the next question says we should find the value of x when y is 3. So to find the value of x when y is 3, now it will be, hence when y is to be 1 over 3 times 24, and 1 over 3 times 24 will give us 8. Sorry, I didn't put the over 3 here. So 1 over 3 times 24 will give us 8. Let me just put over 3 here, and that will give us 8. So that is just how to solve that problem. Now that is for question number 5. I trust we understand the concept of variation. For so far now, I've been discussing majorly direct variation. Subsequent examples will discuss the inverse. Now, this question number 6, it looks as though we have solved it before. Okay, yes, we have actually solved this number 6 before, so we're not going to waste our time solving it again. It's just a repetition of fraction. Now, like I said, please, when you hear inversely, just put 1 over, and if it is square or square root, you just do the same thing. So I think let's leave that. Then the next one, for number 7, if y varies inversely as x, what is the relationship connecting y and x? So if y varies inversely as x, so the relationship between them, when we introduce a constant k by removing this guy, all we have is y equals to k over x. So this relationship between them, and it can also be written as k equals to xy. It's the same thing. Now number 8, given that z is inversely proportional to y and z is 5 when y is 6, find a constant of variation k. So to get that, z is inversely proportional to y. So the constant of relation, or the relationship between them now, is z equals to k over y. Just remove this proportionality sign, then introduce a k. K times 1 is k over y. So the constant of variation now is k equals to yz. So y is given to be 6. Whenever I use a decimal point here, it was just an omission. Whenever I put a decimal point here, just know it's multiplication. It's not actually 6.5. You see this kind of situation mostly when you take competitions like Olympiad. Now 6.5 in this case just means 6 multiplied by 5. So this gives us 30. So the constant of variation is 30. Now number 9. P varies directly as the square of W. Find the value of the constant k, that is 1, when W is 4 and P is equals to 12. Okay? To do that, what we're going to do, P varies directly as the square of W, as W squared. So to introduce the constant now, we have to remove this probability sign by bringing P to be equals to KW squared. So to get our K now, K will just be P over W squared. Now P is actually 12, then P is 12, while W is 4, but 4 squared here is 16, so we'll have 12 over 16, and 4 in 12 is 3, 4 in 4 in 16 is 4, so the constant of proportionality is 4. Now look at this question. Now, if x is equals to 6, when y is equals to 8, in the second statement, when x is equals to 7, when y is equals to 5, then x varies dash as y. It's asking, is it directly or inversely? Now, from your understanding of what these two things actually mean, now let's check it. X is 6 here, y is 8. X increase. It was to be direct variation as x increased because it was 6 here when it came here is increase to 7. Y should also increase if it's a direct variation, but since y is decreasing because here was actually 8 before, if y is decreasing, which actually decreased to 5 now, then it means this is an inverse variation. So our conclusion will be then x varies inversely as y. So this becomes the answer. Then x varies inversely as y. I trust we understand the foundation we have laid so from under variation and how to actually solve those problems. Now let's see what we have next. Okay, now I want to test your mastery, how good you are when it comes to the concept of variation. So I have some questions for you on the screen, and they are quite simple. So for each question I'll give you, let's say, 1 minute 60 seconds to solve. So your question starts now for number 1. What is your answer? Take your time, read the question and see how to solve it. I have my timer with me here. You don't need to pause the video, just continue watching. Get ready to stop. Okay, time up. The answer is 1. Now, were you able to get 1? If you actually did, then thumbs up for you. Now, how is it actually 1? Let's look at it. If P is directly proportional to Q square, and P is 25 when Q is 5, find the constant proportionality. What we'll just do, just listen to my oral explanation. P will be equals to KQ square. Now you trust that. But P is 25, and P is 25 and Q is 5. So Q square is 25. In other words, we'll have 25 equals to 25K. So to get K now is 25 by 25, which is 1. So step number 2, you have 60 seconds as well to do that. Maybe I'll just give you 30 seconds. Anyway, I'm the quiz monster here, so I choose to stop. And the time says time up. So the answer is x equals to ky. It's actually very simple. If x varies directly as y, so it means if I remove the proportionality sign, it becomes s equals to ky. Solve number 3 for me. If x varies inversely as the square of p and x is 2 when p is 4, find the formula connecting x and p. You have to get the formula first. When you get the formula, then you now find the value of p when x is 8. "30 seconds to get the relationship between them. 30 seconds to get the value of p. You have to gain speed whenever you solve problems. Get ready to stop. Okay, let me just set time up. So for the first one, to get the relationship between them, first of all, we have to get the value of the constant k. Now, in this case, we're told that x varies inversely as the square of p. So, if as the square of p, it means we have p squared there. But p is actually 4. So, 4 square is 16. Now, since 4 square is 16, but take note it's inversely. So, what it means that 2 is equals to k over 16. So, to get our k now is 16 times 2, which is 32. So, x will be equals to 32 over p squared. This is the relationship. So to get the value of p when x is 8 from this relationship, this becomes 32 over x, and x is 8. 32 divided by 8 is 4. Then this is p squared, you take note of that. So square root of 4 is 2, so p is 2. If you get that again, thumbs up for you. Question number 4. Y is directly proportional to z, and the constant of variation is 6. Then z is equal to what? What will be your answer? You have 60 seconds to solve this problem. Okay, like 15 seconds to go. Get ready to stop. Okay, time is up. So the answer will be z is equal to 6 over y. Now, how do we get that? Y is directly proportional to z. So what it just means is y is equal to kz. And the constant of relationship is 6. Then z will be equal to what? So like I said, y now since the constant is 6, so it means y is equal to 6z. So to get my z now, z will be, I'm coming, let me say it again. If y equals to 6z, yeah, to get our z now is y over 6. Y over 6. That should be the answer. So z will be equals to y over 6. Kindly ignore this, y over 6. Now solve number 5. X varies directly as the cube root of p and x is 2 when p is 27. Find the formula connecting x and p. While you keep solving, let me actually correct this. We'll say y is equals to y is equals to this. You can just continue solving. Okay, I'll add 15 more seconds to your work. If x varies directly as the cube root of p, take note, and x is 2 when p is 27, find the formula connecting x and p. You have 10 seconds more. Okay, I think I'll set time up now. Let's see the answer. Now, look at the first part. X varies directly as the cube root of p. This is how to write it. If I bring my constant of proportionality, it will be x equals to k cube root of p. Now, and x is 2 when p is 7. Find the formula connecting them. The formula connecting them is actually this, but actually we have to substitute. One substitute to get the formula connecting them. X is 2 and p is 27. So the formula connecting them in real sense is 2 equals to cube root of 27 is 3. So it will be 2 equals to 3k. The answer will be 2 equals to 3k. So the next one, find value of x when p is 8. So substitute into this place, when p is 8, cube root of 8 is 2. So now, but we have gotten, okay, now let's get if we get the value of k there, no, I told you also that the value and the relationship is actually 2 equals to 3k. So k now will be 2 over 3. 2 over 3 multiply it by 8. I think when reduced, I'll have one whole number 1 over 3. That is for question number 5. Then let's continue. Oh, I've actually shown you the answer for question number 6. So for question number 6, if x is directly proportional to y and x is equals to 4 when y is equals to 12, find the value of x when y is 8. So the value of x is actually 24. It's actually 8. How do we get that? Now x is, okay, let me just give you time to solve it and cross check if my answer is actually correct. If my answer is actually correct, let me get my pen so that I can actually pen some things down as well. Okay, take your time, solve it. Now when you're done with number 6, solve number 7. Okay, I'm back. So for number 6, like we said, x is directly proportional to y. So if x is directly proportional to y, we'll have x to be equals to ky. So I'm solving just to confirm what I have on the board, but I trust the answer should be correct. Okay. So x is equals to 1 over 3, y, and y is 12. Y is 12. Okay, let's see this number 6 together. Now, if x is directly proportional to y, so the next step will be x equals to ky. Now, we're told that x is 4, y is 12. So to get our k there, it will be 4 over 12, which is 1 over 3. So if k is 1 over 3, the relationship between them will be x equals to 1 over 3 y. So y is 12 now. Since y is 12, 1 over 3 times 12, the answer is 4. So this answer is actually 4. Okay. Now let's go to number 7. Now if x is directly proportional to t and x is equals to 15 when t is 5, express x in terms of t. And finally, calculate the value of x when t is 12. Now, I'll allow us to solve this. When we're done, we can actually continue while you solve the 8, 9, and 10 as your classwork later on. I'm also solving here. I want to just be sure the answer is supplied here actually correct. If x is directly proportional to t, x is directly proportional to t. So what I have here will be x equals to kt. Then the next thing will be x is 15. This is 15 equals to t is 5t. So my 5k. So my k is 3. So now let's express. When we express what was actually our answer. When we express x is equals to k, I got k as 3, so it will be x equals to 3t. Then the next one, find x when t is 12. So 3 times 12 is 36. We're correct. So you can actually solve number 8, 9, and 10 and cross-check with your answer. So what I have all these. Now let's just see some applied questions. Now the first question I have here as an applied question is actually this, and the question is asking us. Now let's read it together. The question says the pressure P of a gas is 5 atm. The atm just means atmospheric pressure. And when the volume V of the gas is 60 centimeter cube and 10 atm. Okay, when the volume of this is let's restructure the question. Okay, the pressure P of a gas is 5 atm when the volume of the gas is 60 centimeter cube and 10 atm when the volume is 30 centimeter cube. The first question says show the relationship between P and V. Now to get the relationship between P and V, for some of us that actually don't really have the background of science, there's what we call the Boyle's law from science. And what does this law? You don't actually know what the law just a relationship. And this law is just that the relationship between pressure and volume. And the relationship is just as the pressure of a gas increases, the volume of the gas decreases. This is Boyle's law. So in other words, this is an inverse variation. Now how do we know it's an inverse variation? Let's actually check. Now, if we put P is inversely proportional as V, so P will be equals to K over V. Now, but we're told for the first statement, we want to check if the constant of proportionality will give us the same value, then we'll know we're actually correct to state that this is inverse variation. So from the first statement, when P is 5, we have 5 equals to K over the volume there was actually 60. So to get our K now, it will be 5 times 60, which is 300. Now from the second part again, we can actually do the same thing for the second part. The second part we have 10 is equals to K over 30. To get K there again, we'll just be 10 times 30, which is still 300. Hence, so we're sure that this is actually an inverse variation. So the relationship between them is P to be equals to 300 over V. This is the relationship between them. Now, the next question says, we should determine the volume when the pressure is 8 atmospheric pressure. Now, to determine the volume, we'll have the pressure to be 8. So the V now, when the V, to determine the, okay, well, I want to determine the volume. To determine the volume will be 300 divided by P. 300 divided by P, because we want to actually get the volume. So to get the volume is 300 divided by P. Now when we have 300 divide by 8, now you can actually break it down. 300 in 8 will have 150 over 4. Now 150 divided by 4 will have 75 over 2. 75 divided by 2 will have 36.5. So this will give us 36.5. So this is actually the answer. Then the next one is find if the volume is 30 centimeter cube, what is the pressure of the gas? So if the volume is 30, so it will be 300 divided by 30, which will give us 10 atmospheric pressure. So this is just one of the applications. Now let's look at the second part. Now, the second part says if 4 kilogram of meat costs 500 naira and 7 kilogram of meat costs 875 naira, show the type of variation between the weight of meat and the cost. Now, how do we actually get the type of variation we have here? Now let's observe something. When the quantity is 4, the price was 500. When the quantity increased, the price also increased. Obviously, this is direct variation. So let's actually prove it. We'll prove it by getting the constant of proportionality. If we're getting the same value, we'll know it's direct variation. So now, like I said here, this type of variation, the type of variation between them is direct variation. The reason is because when the quantity of meat increases, the cost also increases. Also, for both statements, the constant of variation remains the same. How do we get to know that? So if Q directly proportional to C, and we have Q equals to KC, so our K now will be Q over C. So the Q for the first statement will have 4 over 500. Break it down, we'll have 1 over 125. The same thing for the second part. If we want to find K, 7 over 875 is still 1 over 125. So the relationship between them is Q equals to 1 over 125 C. So the next part, find the cost of 2 kilogram and 8 kilogram of meat. So we're doing the same thing in two places. So to find the cost of 2 kilograms, so we just substitute. We're looking for the cost of 2 kilogram. Okay, let's actually do that. Let me correct some of the things here. Now, if I want to get the cost of 2 kilogram now, the cost of 2 kilogram will actually be 125 times Q. So the first one is 125 times Q, and the Q there is 2 kg. So this will give us 250, and the second part, to get the cost to, it will be 125 times 8, which is actually 1000. So this is the value of when it's at 2 kg and when it's at 8 kg. Now we can also check if it's actually correct. When it's at 2 kg, the cost, we got the cost to be 250. When it's increased to 8 kg, we got it to be 1000. So it's actually correct to be direct variation. So that is that for it. Let's see what we have next. Okay, let me just give us some quick quiz. Now, I think we have 20 seconds per question. Now, look at this question. A variable y is inversely proportional to x squared. When y is 10 and x is 2, what is y when x is 10? You have 20 seconds to solve it, and your time starts now. Time's up. Now let's see the answer. Now let's solve it together. Now, whatever will be your answer, just keep it. The y will solve it together. Now, the first part, y is inversely proportional to x squared. So, to write it down, y will be k over x squared. Now, that's the first thing. Just follow what I'm saying. Y is 10, so we have 10 equals to k over x is 2. 2 squared is 4, so we have k over 4. So, to get our constant of probability is 40. So now we have y now to be equals to 40 divided by x squared. Now the second statement says find the value of y when x is 10. So this is 40. 10 squared will have 100. So 0 cancels 0. 4 divided by 10 is 0.4. Our answer is option C. If you get that, thumbs up for you. Now let's go to the next question, which is question number 2. You can just take a deep breath. If you have a bottle of drink that you can actually help yourself, then when you are ready, let's continue. Okay, let's continue. Now the next question says if y varies inversely as the cube of x and y is 3 when x is 2, calculate the constant of proportionality, and your time starts now. Time's up. Now let's see the answer. Y varies inversely as the cube of x. So to write that fastly, what you just do, just say y is equals to k over x cubed. So now we'll substitute to get the value of k. Y now to get k directly from there, k will be x cubed multiplied by y. So our s is 2, so 2 cubed is 8. 8 times 3 will give us 24. So since we're asked to find the constant of proportionality, the answer is 24, option D. Now the next question, which is question number 3. Now y is directly proportional to x. If y is 6 when x is 2, find the constant of proportionality. Your time starts now. Time's up. Okay, let's solve that without the timing now. Y is directly proportional to x. So to write that, just remove the proportional sign. It will be y equals to kx. So y is 6, so 6 equals to x is 2, so it will be 2k. So to get our k is 6 over 2, which is 3. So the value of k is 3, so option C is the answer. Now let's see question number 4. Now, okay, I just prepared just 3 questions for this practice. Okay, you have some practice exercise here which you can actually lay your hands on, and I trust you actually enjoy it. These we'll have this as well. Things are the 2 practice questions. You can get this material from Just Media, or just send me a mail. I'll forward it to you. But meanwhile, there's a question I actually want us to solve. It's a question I actually want you to solve. We didn't actually finish it the last time. And the question is this particular question. Let's just go back to see. Let's just go back to see the question. Okay, I think question number 8. I want to give question 8, 9, and 10. So I'll give you let me just give you 3 minutes per questions for you to solve. just 3 minutes. And for number one, you can start now. 3 minutes per question. You have spent 1 minute so far. For question number 8, I'm still timing you. Okay, let me actually set my timer. Continue solving. After 3 minutes, you're gonna stop. Okay, let me check your time again. Okay, 1 more minute remaining. Get ready to stop for question number 8. Okay, time's up. Now let's see it together. For number 8, if you want to get the relationship between them, to get the value of k first, to do that, all those do say p is equals to k over q q cube. Now to get the value of k will be p q cube, but p is 8, so it will multiply by 2.5, and q is 2.5, so 2.5 times 2.5 times 2.5. Now in an exam setting, you may be wondering, how do you actually get 2.5 times 2.5 times 2.5? What you have to do is quite simple. Change the 2.5 to fraction. You have 25 over 10. Now that 25 over 10, you can actually choose to reduce it to its lowest term, which is 20. Okay, 25 over 10 in 3 places is 25 times 25 times 25 over all over 10 over 10. Now if we reduce it, this will give us 5 over 2, 5 over 2, 5 over 2. The 2 on the denominator multiply, it cancels the 8. So what I have left is 5 times 5 times 5, so which is 125. So the value of k is 125, and the relationship between them will give us p equals to 125 over q cube. Now the next thing was now for us to find the value of q when p is 216. So to get q now, to be q cube equals to 125 over p, and p is 216. So to get q, it is cube root of 125 over 216. Cube root of 125 is 5, cube root of 216 is 6, so that's how we got q to be 5 over 6. So that is for number 8. So you have also 3 minutes to solve number 9. If m varies inversely as n and m is equals to this, when this, find the value of, okay, yeah, let me just give you 3 minutes to solve that. I'm actually solving with you, so just continue. Okay. You have 1 minute with some few seconds to go. Get ready to stop. Okay, time bomb. The first answer is to get the value of m is one whole number 1/2. Okay, sorry, the over 2 is not actually showing here. Now, how do we actually solve that? It's simple. The first thing to do is you say m very direct inversely as n, so it will be n equals to k over n. So my k now is mn. If k is mn, m is actually 4/3, then n is 9. So 3 here, 1, 3 here, 3. 4 times 3 is 12. So the value of k is 12. So the relationship is m equals to 12 over n. Now 12 over n. Now in this case, I'm asked to find m when n is 8. So to be 12 over 8, 4 can go, that is 3 over 2, which is 1 over 1/2. If you get that, thumbs up for you. Then now let's solve the last question. Question number 10. You have 3 minutes and your time starts now. Ensure you take your time to solve this question. Okay, 1 minute and few seconds to go. Few seconds remaining. Okay, time is up. Now let's say it together. Now the first part, so we should find the relationship between them. To get the relationship between them, we have to get the value of k, and the value of k there is 22/7. How do we actually get 22/7? From the first statement, c directly proportional to k, so to d, to be c equals to kd. So to get our k, it will be c over d, and c is given to be 66 and d is 21. So what we can reduce that down, that 3 in 66 is 22 and 3 in 21 is 7. So the value of k is 7. So since k is 7, so we have c equals to the relationship between them now, 22/7, then multiplied by d. That was how I got this one. Where is my, sorry, I'm actually looking for my cursor. Okay, that was how I got this one. Now the next one is to get my D. To get D, if you make D solve the formula, we'll have 7C over 22, and C is 44 given that term. So 22 here 1, 22 in 44 is 2. 2 times 7 will give us 14. So that was how I got 14. So that brings us to the end of variation. I trust we have been able to understand quite some things here. Then my assignment to you is practice these questions you have on the screen, and also work with time and accuracy. Thank you very much for staying with me. I think I have 2 questions here, these and these. You can engage the service of your teacher in your school or any of your senior colleagues to help you out in some of the problems. Now, thank you very much. That is how far we can go for this particular lesson. See you in the next model and have a nice time. Bye.